This is Mrs. K here with a Paperslide video about the chi-square test. The equation for the chi-square test is a bit intimidating, but with practice you'll find that it's actually really simple once you get used to it. The chi-square test is very important in science because it is a way to determine if the variation that you see in your data is due to chance or if it's due to the variables you're actually testing in the experiment. The first thing that you need to figure out is what all these variables mean. The first one stands for chi-squared. The next symbol, which looks like a big capital E, is the Greek letter sigma. It means sum. The O stands for the data that you collect. We call that observed data, hence the O. Then the E value is the expected values for your data. In an experiment, you can figure out your expected values before you start. The chi-squared test lets you compare these expected values to the observed values. Let me give you an example of expected and observed values with these coins. If I flip a coin 100 times and I get 60 heads and 40 tails, well, is that due to just chance, or is there something wrong with the coin or the way that I'm flipping it? The chi-square test lets us answer that. What I'm thinking in my head about what will happen with the coins is called a null hypothesis. A null hypothesis is the theory that there is no significant difference between the observed and expected frequencies. If I'm flipping a coin 100 times and I get 60 heads and 40 tails, that is the observed values that we get in an experiment. But there are also expected values because you know that it should be 50 heads and 50 tails probability. With the chi-square test, we can look at measurable data and determine if there is a statistical difference between the observed and the expected values. The best way to get good at the chi-square test is to do some problems. Before we get to the problems, there are two terms that we need to define. One is degrees of freedom and the other is critical values. The whole point of a chi-square test is to accept or reject our null hypothesis. So you have to either exceed or don't exceed your critical value. First, we have to figure out what that critical value is in our chart right here. So we have this thing called degrees of freedom. Since we are comparing outcomes of data, we have to have at least two outcomes in your experiment. In this case, heads and tails are our two outcomes. Other experiments might have more than two outcomes. To get your degrees of freedom, take the number of outcomes and subtract 1 from that. In our case of coin flipping, we have 2 outcomes minus 1, so we have 1 degree of freedom. So we figured out that we have 1 degree of freedom in our coin flipping case. Next, we need to determine the critical value. In our class, we will always use the 0.5 value. That is the column right here that's highlighted in yellow. The 0.5 value is being 95% sure that you are appropriately accepting or rejecting your null hypothesis. If we really want to be sure, we should use a value like 0.01, which is being 99% sure. In the case of our coin flipping, our degrees of freedom was 1, and we line that up with the 0.05 column to find our critical value, which is 3.841. When you calculate chi-square, if you get a number higher than 3.841 for this experiment, then you reject your null hypothesis and propose that there is something other than chance that is causing us to get more heads than tails. If you don't exceed the critical value, then you accept the null hypothesis. For our coin flipping, we flip the coins 100 times, so we expect to get 50 heads and 50 tails. If we put 50 for our expected values for heads, and so far our expected value, we put 50 for our expected values for heads and for our expected values for tails. For our observed values, we got 60 heads and 40 tails. Now let's apply the chi-square to get our critical value. Let's take our equation and plug in our values for both the heads and the tails column. So we do 0 minus e squared divided by e for both the heads and the tails values. So for heads it's 60 minus 50 squared divided by 50 for heads, and that ends up being 2. Then we do 40 minus 50 squared divided by 50, which also turns out to be 2 for tails. Now we need to add these values, our 2 and 2. since the big E means sum. So if we add 2 plus 2, that equals 4. So 4 is our chi-square value for our data. Now let's take a look at our critical value. Remember, our degrees of freedom was 1, since we had 2 outcomes minus 1, and that 2 minus 1 is 1. At a 95% certainty for 1 degree of freedom, our critical value is 3.841. So we got 4 for our critical value, and 4 is higher than 3.841. So we reject our null hypothesis. Our coin must be rigged, or I'm flipping it incorrectly, since rejecting our null hypothesis means that something other than chance is at work.